Hi, everyone. Thanks for joining me to learn a little bit more about Fluree. So we have about 7 or so minutes here to give a brief overview on what we do, why we do it, how we do it. And of course, we're available. We have a booth at the event if there's any follow-up questions or you'd like to talk more. One of the things I want to make sure I point out up front is that while I'm going to just be describing some pieces of Fluree in this session, the technology is open source. You can go to our website to the Getting Started button, download Fluree, run it on your local machine, play around with it, run through exercises at our documentation website. Or we have a on-demand version of it as well, so you can play with it in the cloud if you like. So I would encourage you to do that if any of this interests you or you want to just get a little bit more hands-on on exactly what it does. I'll go ahead and share my screen. I have just a couple of slides to walk through. So when we talk about Fluree, we talk about Fluree being a data platform. So not just a database. We do things that in a traditional model, you would have to do inside of an application server. We move things like enforcing data shapes into the data layer. We do things like moving data security into the data layer. And we do this to enable data ecosystems, a data-centric view of the world. So where we're connecting different data sources, and we're doing it outside of the confines of a typical application architecture and a typical application stack. This is a slide I did show in my earlier presentation. It's the only one that will be duplicated. But just to contrast what this platform is for and sort of sets the stage for some of the capabilities we have and the reason why we have them. So we like to draw a contrast between an application-centric view of the world and a data-centric view of the world. Fluree is I guess shouldn't have to be stated. Just by our presence of being here at this conference, our view is very optimistically and from a product standpoint towards a data-centric world. So that is absolutely where we feel like things are headed. And we have built our technology to support some of the very unique requirements that these ideas bring up. So I'll highlight just a handful of things that we need to think about and how we view those contrasts between an application-centric approach and what we need to accomplish in a data-centric approach to make this vision a reality. The first and really the obvious one that drives a lot of these others is just the interaction model. A typical database in an application-centric world is a one-to-one system. There's one producer of data or updates. There's one consumer of data, and that's the application that sits in front of the database. So in a data-centric world, we have greatly expanded that universe and that potential. There's many data producers, many people trying to update data, whether it's a master data management service within your organization or it's something where you're exposing data outside to partners or customers outside your organization. The idea that different individuals or organizations can produce or actually transact data is there. And of course, the opposite of that in data reads, we also have a many model where it's not just an app server talking to a database, but it could be all kinds of different applications. And again, they could be run by people not even within your organization. So it challenges our idea of security and how we think about securing data. Well, in a one-to-one model, security can pretty easily be coded into the application server since it's, by nature, the only thing designed to consume the data. So it can have a completely open interface, an open pipeline or channel to the database. It could run everything as root, if you will, because it is the only thing that can, in fact, talk to the data. It can then secure everything in custom code. And that's a perfectly fine thing to do, although it does result in your security rules being embedded in, potentially complicated code that someone has to look at to try and decipher, but it's fine, it works. In a data-centric model, we need a data-driven approach to security. And in fact, we really need the security to be co-resident with the data. Otherwise, we're going to have all these applications or consumers implement, hopefully, the identical data security rules, but implement them over and over and over again, and hopefully maintain them properly over time. So it really drives this need of moving security for data into the data tier itself. From a capacity standpoint, in an application-centric world, we have a central or fixed capacity because we have only one channel into our data. Here, we may have multiple consumers, and we need to exist in a world where demand might be very dynamic. I may have multiple people requesting data that I have little control over those people, and we need an architecture that supports this sort of easy expansion and contraction of capability. From an analytics standpoint, in an app-centric view of the world, things like ETL, plus data lakes or warehouses. And again, because our security is custom in the code, we have to re-implement security here. Or we just don't do it, and we limit access to the data lake or warehouse, which is often what the approach is. Of course, that's a challenge to get the right data to the right people at the right time, because we've limited the audience who can even see the data. And of course, in a data-centric approach, we need a native approach to being able to combine data across sources. And as it relates to external consumers of that data, of course, here our common tool is custom APIs, which come with them a pretty substantial cost, not only for you to develop them, but for all your data consumers, because they have to write custom code to custom consume your custom API. And then, of course, all of you need to maintain it over time. So these costs can really add up. And if they're not properly maintained, this is where a lot of our security vulnerabilities come in. Where here we want to expose in a data-centric world just a native standards-based interfaces into data. We want people to issue a query in SQL if that's what they know. And Sparkle, of course, is what this community would want people to issue queries in. Or maybe even just GraphQL, because people are used to using like a MongoDB, a document-style database, and GraphQL is probably the ideal interface to getting into data shaped like that. And we want the security driven by the data so that it doesn't matter what I query. I don't need a custom API and figure out all these APIs. I just issue a query for the data I want, and either I can see it or I can't based on my identity. So to address some of those needs, we have the platform, which we often refer to as a data stack, because again, it's a lot more than just a database. So I'll walk through some of these layers of this onion, and they each build on top of each other. So at the foundation, we have trust. We want to make sure any data in the system has provable provenance, that anyone can say, hey, has someone messed with that data or tried to tamper it? Who put that data in there? When did it change? All of that should be native in any sort of data platform, especially one that needs and requires collaboration across multiple entities. Semantics, of course, topic very familiar to this audience, is the next thing we need to wrap around it. So when we look at semantic web technology, we give the ability to allow machines and other entities to infer the meaning of that data that's sitting in our repository. Security is this next piece. Again, we want data to be able to defend itself. And our approach to this is a capability we call smart functions. And what smart functions do is it's business logic that you can attach to different datums. And you can attach it by saying anything with this predicate or sort of column in a traditional relational standpoint. Anyone trying to look at anything in this column, execute this business logic to validate whether or not they can do that, or everyone looking at this row or this class of data. So we embed those rules as smart functions, and they control not only who can see what data, who can update what data, but they also help control the shape of data, making sure we have good data coming into the system and validating data in real time against the current state of the data. Then we need to wrap time around this, because we can't really collaborate around information, anything, if we can't have a consistent view of the world, and time gives us that consistent view. So if a database, a traditional database, is constantly changing from underneath your feet, and you're trying to have two systems have a same view of the world, it's actually impossible to do in a traditional database system. You have no guarantees of that. Fluree allows time travel, allows you to issue queries or lock in a database version at a specific moment in time and issue queries whenever you want, now or years in the future, for that database at that moment in time. And you're guaranteed consistent results. And again, provability or provenance going all the way up the stack. And of course, then we want to layer the ability to share data. So instead of building custom APIs, we want to expose rich interfaces like Sparkle queries, SQL, GraphQL. And because it sits on top of time and it sits on top of security, it means anyone can query for anything they want. They can describe the data and the analytics they want in the query. We don't have to get involved in building hundreds or thousands of APIs for every conceivable use case. We put them now in control of the data they want to see. But because we're securing the data at the source, every user effectively has their own custom database that only has the data in it that they have permission to see. And of course, they have this time slice where they can get to every version of the data that ever existed. I'll conclude with saying we deploy this with a very unique architecture that decouples the updates from the query side, and it allows the database to actually exist as a library that can scale independently, it can scale linearly, it can be embedded inside of applications, inside of a Node.js application. You can run the entire database. It gets away from this idea that to issue a query, I have to send these statements across the internet to some physical database server and wait and get back a response. So it not only drives scalability, it drives a lot more interactivity around the data. So it's a very powerful and very cloud native architecture that we end up supporting there. And with that, I will wrap up, and I appreciate you coming here. And again, we have the booth if you have additional questions, and look forward to seeing you all around the show. Thank you.